Let me welcome you to the 13th lecture of NPTEL online certification course on network analysis for mines and mineral engineering. This lecture title is lowest cost schedule and optimum schedule. Like every class, let us retrospect what we have covered so far. In previous lectures, the process of identification of slacks in non-critical jobs are discussed. It has also found that the total cost of a project depends on the direct cost and indirect cost. Direct costs are directly depend on the man, material, machine, this pricing and does not depend on the time. It is depending on the time and reduced with the time. Indirect cost is basically time dependent, not the man, material, machines dependent, and that is why it increases with the time, and generally indirect cost comprising lighting, security, etc. Direct costing is the man, machine, material cost, that is which is considered as the resource cost also, and indirect cost is completely time dependent and direct cost is both resource and time dependent. Thus, the cost of a project is also dependent on the duration and on the material also. The job duration can be expedite or can be stretched also. So, that is also discussed in the last class. In this class, we will discuss how we can schedule a network, reschedule a network to achieve the lowest cost network by expediting or crashing the different parts of the job. So, last class, in the last slide we are discussing around about the expediting of the job, and we are discussing how the normal time we are coming out, and from normal time how the minimum time is we are considering, and then there are options how we can crash or expedite the projects. Now, suppose this is the total cost curve, this is the total cost curve we are considering, and say this is the duration, normal duration where we are lying at this position. This is the minimum duration, which that means we can reduce this time to this time, but if we look into the cost component, we can find the total cost of the project initially it is reducing, then it is again increasing. So, there is a point where we can have a minimum cost for the project, but though the time is not minimum. So, this operating point is called optimum point, this is called optimum point, where we believe to run our project more generously. So, the direct cost and indirect cost are varying with the duration of the job or the project, and resource requirements, the project can be performed at different duration and time, and the optimum point must be considered where the total cost is minimum, but the direct cost and the indirect costs are optimum. So, direct costs are like this, indirect costs are like this, and that is why this is the optimum point on which we are operating, or more precisely if you are considering probably it is lying this and this one is lying this. So, that is why this is the operating point. So, the lowest cost point where we are we can run our project, that means running the project for that particular condition, our total cost of the project will be minimum. The duration of that point where the lowest total cost is achieved, that is called the optimum duration, or that schedule is considered to be the optimum schedule. Now, to understand it more precisely, let us consider a simple network for the scheduling. We have given in red these 3, these are the basically normal duration of the particular jobs, and this blue which is given in blue color, these are given in blue color, is the minimum time requirement. In last class we have given one example of baking this one. So, this is the minimum time requirement for completion of the job by expediting or giving the all additional resources to that job, then also we cannot complete that job beyond this given hour, which is given in blue color. So, that means, if you are considering job A, the normal duration of job A is 4 and minimum job duration is 2, and to reduce this job from 4 to 2, the cost required is 4. That means, which is given in green color here. So, if you are looking at this, this is the normal duration, this is the reduced duration or the minimum duration, and this is the cost of reduction or cost of crashing, okay. And it is expressed in unit price divided by unit duration. So, this shows us that if we are trying to reduce the job A from 4 to 3, if it is 4 days to 3 days or maybe 4 hour to 3 hour, we have to deploy some additional man or machine or maybe material, and that cost will be 4 maybe say unit US dollar or Indian rupees, whichever it is. If we reduce it from 4 to 2, then the cost is 4 into 2, that is 8 unit. So, that is why this cost of reduction is expressed in terms of this. That is why we have earlier also we have told we are considering it is on linear basis. Say cost from this to this, it is 4, it is 2, and this is the point. Say this is x price, this is x minus 4 price, this is x minus 8 price. So, this is the cost of reduction of this job for these cases, and this is direct cost. Whatever is given here is direct cost, indirect cost is not given on the job. So, that is why the green bracket is basically the cost of crushing in rupees per day or unit cost per unit time. There is another part is the indirect cost, which is considered separately. So, our indirect cost is 4.5 rupees per day or 4.5 unit per day or per unit time we are considering. That means, the total cost of this project, if you are calculating, say for it is x A, this is x B, this is x C, this is x D is the cost of this project for normal time, which is given in red color. So, that means, total direct cost of this project is x A plus x B plus x C plus x D is the total project cost. Now, what is the total indirect cost? The total indirect cost, say this is T is equal to 12, 4 plus 3 7, 7 plus 5 12, 4 plus 7 11. So, 12 is the total minimum time to complete this project considering the normal time. So, this T into 4.5 plus, let us consider it is x T, that is the total cost, direct cost. So, this plus x T is the total cost of this project. Okay. So, now if we are altering from this, suppose if we are reducing this cost, then this cost reducing this duration, this cost will be increased, but as this is a critical job, this cost will be indirect cost will be decreased. So, basically we have to find out first the total cost of the project in the normal duration, then we have to find out what is the change in the duration in the other activities, so that can be changed. So, as every activity must be performed to complete the project, the base cost of every activity must be paid. This cost may be required as fixed or sunk cost of the project, and cost of crushing represent the slope of cost time trade of lines. So, this is very important, and if you see this table, which is basically given us the activities, their normal job durations, their minimum job durations, and their cost of crushing. So, now if you see, there we are having two possible paths. This path 1 is 1, 2, 4 nodes, path length of 11. Path 2 is 1, 2, 3, 4 node of 12, path length of 12, and that is the critical path. So, normal project duration is 12 hours and or 12 days, and this is the critical path. So, the cost is now very understood, it is the 12 into 4.5 plus whatever is the direct cost, that is x t is coming. So, as it is the additive component, we can consider this is the fixed cost, and any variation from these must be considered henceforth. So, now how we can crash it to find out the optimum schedule where the costing must be minimum? Let us check it. So, our first step is to calculate the cost for the normal duration, and you know we have considered the direct cost of O. You actually you may consider it is 0 also, because that is fixed cost, it will be cancelled, and this is the indirect cost. So, total cost is coming basically if it is O plus 54, we have discarded this because that is the fixed cost, it is always there, and the change in that will be reflected as this minus that. So, that is why we can discard this in the calculation, or you can have O plus, or you may have P plus 54 as the total cost of the project. So, as it is the base price, it can be or marked as the x also you can consider. So, now this is the first case in which we have to find out the total cost of the project for the normal duration. So, now let us see what we can do for the second step. In second step, we can find out the critical path. The critical path is this one, and this critical path, the lowest cost of crushing is lying with the D, which is 2 unit. Here it is 4 unit, here it is 4 unit, it is 2 unit. That means, if we reduce this one, the impact on the direct cost or the increase in the direct cost is minimum, and the decrease in the indirect cost will be effective to us. So, if we reduce, we have seen there are two paths, path 1 is of 11, path 2 is of 12, and in the first step, in this step we can consider this one, because both the paths are unequal, for crashing it of 1 day to see the what will be the impact. So, this crashing it for 1 day, because D can be crushed for 3 days, but then the critical path changes if it is more than 1 day, and it will be same with the other path. So, if we crash it for 2 days or 3 days, it will not change the critical path, it will change the critical path to this path to this path. In that case, our indirect cost will not be changed. So, our first job is to shorten it and make it equal to the other path which is its nearly positioned, so that the both will become critical, and if we will carry out this if and only if it is giving us some cost benefit. So, now D can be shortened one day. Why D? Because it is having the minimum crushing cost than other two activities in the critical job. So, now D can be shortened by one day, and if D is shortened by one day, what will be the cost impact? The savings in the indirect cost is 1 into 4.5, that means 4.5 unit. The increase in the direct cost is 2 unit. So, the total cost will become increase in the direct cost of 2 unit and decrease in the indirect cost of 4.5 unit. So, the total cost will become 51.5 unit, or this O plus 51.5 unit, whichever you are considering. So, that means there is a reduction in the cost, but the normal time of completion 12 is now reduced to 11, that means the time duration is reduced. Now, let us see what will happen, because now our both the paths are critical. What will happen if we wish to crush it further. Now, in this case, in the network T is equal to 11, you can see both the paths are critical and both the paths are critical. Now, if we wish to crush, in that case either we have to crush a common job, that is A. So, that means if we crush A, that will reduce the total job path. We have to see whatever is the impact, or our second option is that we can crash this one and this one, or we can crash this one and this one. So, our options are either crashing of A, which is a common job, and in that case crashing cost is 4, crashing days maximum available is 2, 4 to 2. So, 4 to 2 crashing days available, and possible days of this savings are 4.5 minus 4 per day. So, it is indirect cost will be reduced by 4.5 unit and direct cost will they are at 4 unit. So, the costing is 0.5 unit savings, that means minus 0.5 unit is the costing. So, savings is this one. If we are considering the second one, where we will crush B and C, the crushing cost will be, here it is 1 unit, here it is 4 units. So, 1 plus 4 5. We are having possibilities of crushing 4 days in B, 7 to 3, 4 days available in B, 2 days available in C, 3 to 1 is available to us. As we have to crush both, so the minimum of that is only possible to crush. So, that is 2 days available here to crush, and the per day impact is thus 4.5 minus 5, that means it instead of saving it will basically costing to us. So, this will increase the costing. Whatever is the third option, we can opt for crushing this one, we can opt for crushing this one, and you remember that we have already crushed this one from 5 to 4. So, now our available days for crushing is only 4 to 2, and considering this we are having option, the cost impact is 1 plus 2 is 3 unit, and if you see the maximum days can be crushed here for B is 4 days, for D is 2 days, because it is already reduced 1 days earlier. So, the most possible days between 4 and 2 is 2 days only, in other case it will not be possible, and the cost impact you can see or savings per day is 4.5 minus 3 is 1.5. So, the savings, if you are looking at only at this savings per day column, you can find out this one is highest. That means, if you go for crashing job B and job D, you can save maximum. So, let us go for crashing this B and D for 2 days. Now, for crashing this one, B will become 5 days normal time now at this present point, and D will become 2 days, that is the minimum at its minimum time from 4 to 2. And if you calculate the direct cost, then again we have gone for 2 days additional reduction of this one. So, 4.5 into 2 days are the cost saving in the indirect cost, 3 into 2 6 days is the increasing in the direct cost. So, the total cost is coming, earlier it was 51.5, if you minus 1.5 into 2, that means 3. So, it is 48.5 will be the total cost, or you may have that is O plus 48.5, whichever is the total cost you are considering. But now our project duration is reduced to 9 days, 4 plus 3 plus 2, 9, 4 plus 5, 9. So, both the paths are now critical, and our now present cost is at 48.5. Should we crash it anymore? Whether we should crash it anymore, let us see our step 4. So, in the step 4, you can see the earlier as it is shown in the earlier, the duration is T is equal to 9, both the path is 9 hours or 9 days path, both the path are critical, and in this case what are the options we are having to crash or expedite the job? Either we can go for crashing this one for 2 days, or we can go for crashing these two one simultaneously, whichever days are possible. Now, this is at its minimum position and we cannot crash it anymore. So, the options of crashing this one and this one is no more existing. So, that is why let us see what are the options we are having, either to crash a common job A, or to, actually this is the spelling mistake, or to crash a single job of each path which is B and C. So, let us see the cost impact, again prepare this table. A, the cost of crashing per day is 4, the possibilities is of 2 days, as it is the single job, the possible days for crashing is also 2 days, and the savings are 4.5 minus 4, that is 5 days, that is 5 days savings per 0.5 unit savings per day is available with this. Now, if you are considering the other option, in other option our cost impact is 1 plus 4, 1 plus 4 is 5 unit, 2 days, now it is 2 days, 5 to 3, 2 days available for crushing in B, 3 to 1, 2 days available for crushing in C. So, the total possible days are also 2 days here, and if you see the cost impact is 4.5 indirect cost savings per day, additional crushing cost is 5. So, the savings is basically minus 5, that means it is actually not saving, it is increasing the costing of the term. So, if you are comparing this, column only, you can see this point is giving us some saving, this is basically costing to us. So, we can opt for this one, that means a job may be crashed for 2 days and it will become 2, and that can give us an additional costing of 4 into 2, but an additional indirect cost saving of 2 into 4.5. That means, by calculating this, earlier we had 48.5 minus cost savings is 0.5 into 2 is equal to 1. So, it is becoming 47.5. So, it is coming 47.5, or you can express it in some fixed cost O plus 47.5 is the total cost. So, now our new network is showing this one, where A is 2 hours, B is 5, C is 3, D is 2. So, the total project time is 7 hours or 7 days, whichever it is. So, now should we go for further crashing, whether it is giving us benefit or not? Let us check that one again in step 5. In step 5, we are now at this position, and we can see both the paths are now critical, and we can not crash A job and D job anymore, because these two are at their minimum time. So, we cannot crash it. Now, we are only having option, either we can crash this one or this one simultaneously, that is the only option we are having. So, what we are having option? We are having option that B and C can be crashed together. The cost impact is, direct cost impact is 1 plus 4, that is 5. Possible days of crashing available is 2 days, but instead of savings it is giving us the costing. So, that is minus 0.5 is the savings per day, and if we carry out this one further, still if we are carrying out to achieve the minimum duration or something like that, we can find out a new schedule like this, but this is costing us additional direct cost of 5 into 2, indirect cost will be reduced by 2 into 4.5. So, this is 10 minus 9 is 1. So, the earlier we had 47.5, now that is increased to 0.5 into 2. So, that is becoming 48.5. So, now our total cost is increased, if you can have it is O plus 48.5 again, if you are considering that fixed cost O is there. So, that means though we are able to reduce the total duration into 5 hours or 5 days, but it is not our minimum cost. Our minimum cost was 47.5, which we have achieved at t is equal to 7. So, that means if you plot the time versus total cost curve, if you see that on the 12th day it was 54, on 11th day it was 51.5, on 9th day it was 48.5, on 7th day it was became 47.5, and on 5th day it was became 48.5 again. So, if you plot this, you will find out the minimum cost was obtained on the 7th day, and it was of 47.5 unit, and this schedule will be called optimum schedule. That means, while the time versus cost is plotted, it can be seen that the cost is lowest at the particular schedule, and the schedule will be accepted as the optimum schedule. So, while the time is lowest, but the cost is not lowest, that gives us the schedule for minimum possible time to complete the project, that comes is at this position 5th day, but it may cost us more. So, logical option may have that other constants also, and could be used in the network analysis for optimizing profit, increase sales, etc. In this case, one particular matter is very important, that while the re-evaluating the project network is going on, and it has been found that a project is got delayed, that time it may be possible that one has to go for this option, though it is not accepted in that particular financial condition, but to address the project due date, this may have to be opted for. So, our final project will be accepted project schedule will be of 7 days, and that may be opted for. So, that is very important, and we are able to now go for the optimum project network that can be considered, that can be followed. Thank you.